Welcome my dear friends to my KTM video playlist. Today we are going to discuss about example on belt drive. Especially it is based on creep. So let's see first of all the description of the given problem and try to understand this description with the help of this figure. Actually it will be not given to you in the examination, but it is only shown over here to understand the description. Now let's see the description. The power is transmitted from a pulley 1 meter diameter. Here you can see the power is transmitted from this pulley to this pulley. So this is the driver and this one is the follower. So here the power is transmitted from a pulley 1 meter diameter. So here it is written D1 is equal to 1 meter. So this is the diameter of this pulley running at 200 rpm. So the rpm of this pulley is 200 to a pulley 2.25 meter diameter. So here the diameter of this pulley, that is 2.25 meter, by means of a belt drive. Here you can see this is the belt. Find the speed lost by the driven pulley as a result of creep. So here we are going to find the speed loss by the driven pulley due to the creep phenomenon. We have discussed earlier what is exactly the meaning of creep. If you want to understand this phenomenon, then go to my video playlist. If the stress on the tight and slack side of the belt is 1.4 megapascal and 0.5 megapascal respectively, that means the stress in the tight side of the belt is 1.4 megapascal and stress in the slack side is 0.5 megapascal. The Young modulus for the material, especially for the material of belt, is 4 megapascal. Now first of all write down the given data with usual notation. So first of all here the power is transmitted from pulley 1 meter diameter, so it is D1. Then it is running at 200 rpm, so N1 is equal to 200 rpm. Next, to a pulley of 2.25 meter diameter, so it is D2. Next, find the speed lost by the driven pulley as a result of creep if the stress on the tight side is 1.4 megapascal. So you can say sigma 1 is equal to 1.4 megapascal. And you know that megapascal, that is 10 raised to 6 Newton per meter square. Next, slack side stress is 0.5 megapascal, so it will be sigma 2. Next, the Young modulus for the material of the belt is 4 megapascal. So this is modulus of elasticity, so it is E. Again, megapascal is equal to 10 raised to 6 Newton per meter square. Now here I have converted megapascal into Newton per meter square because of here we have taken the diameter in meter. So you have to convert it into Newton per meter square. Now let's say N2, that is the speed of driven pulley. If you neglect the creep, then we know that N2 upon N1 is equal to D1 upon D2. That is actually the speed ratio. So first we are going to find the N2, that means the speed of the driven pulley without considering the creep. So now put the value of N1, D1 and D2 in this equation that is given to you. So you just put it over here and from this equation you can find the N2. So this is 88.889 rpm. You know that N2 is the speed of the follower, or you can say the speed of the driven pulley, and that's why the unit is rpm. So this is actually the speed of the driven pulley without considering the creep. Now let's see the second case. Now consider the creep. Now by considering the creep we are going to find the N2, that means the speed of the driven pulley. So now you look at this two equation carefully. Here this is the speed ratio n2 upon n1 is equal to d1 upon d2 without creep. Here again n2 upon n1, that is actually the speed ratio, that is equal to d1 upon d2, but this is now over here added, and that is actually the factor due to the creep. So if the creep is given to you, then you have to consider this factor, and that is always less than 1. Keep in mind over here, in the numerator it should be sigma 2 and in the denominator it will be sigma 1. And here always sigma 1 is greater than sigma 2. And you know that sigma 1 is the stress in the tight side and sigma 2 will be the stress in the slack side. Now put the value over here. So n2 is our objective and remaining data you know very well, that is given to you. Now simplify it. So this is as it is. Now if you take the square root of this one, then you will get this one. Similarly over here you can understand. Now you can find the n2 from this equation. So you will get n2 is equal to 88.878 rpm. Here this n2, that is the speed of the driven pulley by considering the creep. Here this n2, that is the speed of the driven pulley without considering the creep. And our objective is to find the speed lost by the driven pulley as a result of creep. So now you can understand how you can find the speed lost. This is actually the speed without creep, and this is actually the speed by considering the creep. So here you can see this is the speed loss because of this value is greater than this one. So why this value is less? Because of that is due to the creep. So now you can understand what should be the value of the speed lost. So can you give me the answer, my dear friend? How you can find the speed lost? Yes, it is very simple. Now you can say speed lost by the driven pulley due to the creep, that will be the difference of these two values. So you can say 88.889 minus 88.878. So this is actually the speed lost due to the creep. So that is your answer. So make a box. Keep in mind that in the examination always you should make a box of your answer, and at the end unit must be there. If you have any question, then write in the comment box. I will be back. Thanks my dear friends for watching this video. Press the like button to appreciate it.